Let's now talk about procedural abstraction. In C++, we can look at it as the black box analogy. In the context of programming, a black box refers to something that we know how to use, but the method of operation is unknown. For instance, a person using a program does not need to know how it is coded. Instead, a person using a program only needs to know what the program does and not how it does it. If we are going to put functions and the black box analogy together, it is where a programmer who uses a function needs to know what the function does and not how it does it. Therefore, a programmer needs to know what will be produced if the proper arguments are put into the box. And in this case, what matters is that the programmer knows what will be produced by the function if the proper arguments are provided. This would give way to what we call information hiding. Designing functions as black boxes is an example of information hiding. Actually, the term information hiding is more popular in object-oriented programming, although we will not be touching that for now. As we progress later in the end of our subject, we will have a little introduction about object-oriented programming, hence information hiding. Going back, the function can be used without knowing how it is coded, which is basically the concept of black box. Also, the function body can be hidden from view, which means all we need to have is a comment which would tell the programmer what the function does, what it will produce, given that the right arguments are provided. Talking about function implementations and the black box, designing with the black box in mind would allow us to change or improve a function definition without forcing the programmers which use the function to change what they have done. Also, to know how to use a function, to simply read the function declaration and its comment, just like this one. As you can see here, we have the following definitions for the function uBalance. Without looking at this definition, we can simply look at this function declaration, the required parameters, and of course, the comment which describes what this function does. This is an example of a black box analogy applied to a function. In C++, procedural abstraction is a very important concept. In this case, procedural abstraction is writing and using functions as if they were black boxes. Procedure is a general term meaning a function-like set of instructions. On the other hand, abstraction implies that when you use a function as a black box, you abstract away the details of the code in the function body. Hence, we are only concerned about what the function does and not how it does it. Talk about procedural abstraction and functions. When we apply procedural abstraction to functions, We write functions so that the declaration and comment is all that we need to use the function. Basically, it would tell us what the function does and what we need to provide to the function in the form of arguments. Of course, function comment should describe the returned value as well. The variables used in the function, other than the formal parameters, should be declared in the function body. Talking about parameters, functions are designed as self-contained modules, which means everything that a function needs to do are all indicated in the function body. Of course, in the concept of black box, different programmers may write each function. Also, you also need to choose meaningful names for your formal parameters in the same way that you choose meaningful names for your variable names. Formal parameter names may or may not match the variable names used in the main part of the program. It does not matter if formal parameter names match other variable names in the program, which means all the variables contained in a function are enclosed only in that location. Therefore, it does not matter if we have a variable of the same name outside of that function in our program. Here's an example of a function in which we use the following parameter names. And in this case, we use them to contain the values that are passed during the function call, in which those arguments will be plugged into these parameters, and also in the function definition or in our function body, whatever values were plugged into these formal parameters will be used in our function definition. Here's an example which shows the concept of black box analogy as well as abstraction in functions. Here's a case study which would work in the following manner. In this case, the program would tell us which size of pizza is the best buy, and of course, it will involve a number of computations as well as some problems that needs to be solved using the concept of procedural abstraction, in which we determine the input and output of our program. And of course, we will also break down our program into smaller parts. And in this case, we are going to call them subtasks, which would also satisfy the solution that is required by the original problem that is broken down into smaller and more manageable subtasks. And of course, there are instances that the subtasks that has been identified can actually be integrated and implemented into a single function. And of course, following the rules that we mentioned a while ago, we also need to give appropriate name to our functions. And following the concept of our black box analogy and information hiding, We can see here that we provided the following comment to give information about the function unit price, as well as what this particular function does and what particular value it produces after it has been called, as well as the required parameter or argument that will be provided to this function whenever it is called. Right after that, we will now translate each subtask into an actual algorithm, as well as the variables that we will need for each subtask. And of course, we now have the pseudocode for this program, which will now show how it would actually look like if we are going to convert those subtasks into actual program statements. Of course, the best way to understand this case study is to look at the source code that we provided and, of course, to run it yourself. The sample code for this case study has already been provided to you, so I expect that you explore the source code and understand how the program works. Of course, going back to the concept of how we solve a particular programming problem using procedural abstraction, of course, we start with the program testing once the solution has already been implemented into an actual source code. Of course, we need to perform program testing in which our program will be compiled and run and try to see if there are errors, whether it is syntax error or logical errors. By doing so, it increases our confidence that the program that we made will actually work. And of course, when running our program, it is also helpful that we first provide it with data with a predetermined output. And also, we need to run our program using several different sets of data. That way, we will be able to see some other errors, especially the logical error, which are more difficult to debug. In this section, we now know what a function declaration is, as well as the importance of placing a comment into your function declaration. That way, a programmer will be able to know what the function does without knowing how it does it. Also, we now know what it is to use the black box concept in programming. That way, we will be able to write functions that can be easily used by other programmers without having to see the details of it, especially in its function definition. All we need is the function declaration and the corresponding comment which tells the programmer what it does, what it produces, and of course, the arguments that will be required whenever the function is called.